Alright, GIS friends, we are back following up from last week's practicum, and we actually have a lot to cover today because this is the day that we are going to start creating some data, and we're really going to start making headway towards the work that you have to do for project 1. So we're basically just where we left off because we saved our QGIS project at the end of the last practicum, and so when we open it back up we should be right where we left off. And we see we have our 3 layers, WHS sites on top, the Google satellite in the middle, and the SRTM DEM at the bottom. And just to recall, the check boxes, we can turn them off and on to view them independently or to have them layered as we like. And if you'll recall, before we saved, we cleared our filter where we were filtering for villages. So we're looking at the entire WHS survey database, all the sites that were recorded in that survey. So we got a few things on tap today. I'm going to show you how to make some quick and dirty maps with scale bars and north arrows, things that we call map decorations. These are not full-blown cartographic products. We're going to do that next week where we look at the print composer, but we're going to take a look at how to make just some quick map display type maps. And then we're going to do a couple of fairly simple creating vector overlays, grids and buffers and that kind of stuff. I'll show you how to do some very simple spatial querying. And then we're going to cover digitization, and that's really where you're going to probably spend the most amount of your time when this practicum is over. You're going to keep digitizing to create the new data that you're going to use and analyze for project 1, and starting next week with thematic mapping and a few other things like so. So let's start with map decorations. Map decorations are things that go on a map that are supposed to add some interpretive value. And I really see mainly just 2, maybe 3 map decorations that are really necessary. A scale bar to tell you exactly what the distances mean on the map, and potentially a north arrow, although that's not always strictly necessary. And a third one might be something like a locator map, which we'll deal with when we talk about thematic mapping. You can add text labels and images and all kinds of stuff, and if you get into that, which we'll talk about next week, you really got to ask yourself if it's necessary. But certainly a scale bar is necessary. So I'm going to show you how to add a scale bar and a legend to the map display window that you have open over here. So what you're going to do is go to the View menu at the top and go halfway down here where it says Decorations, and as you hover over that, you see a few different things that you can put here. Let's select the scale bar, and we get the scale bar decoration window. So we click Enable and we hit Apply. And by default, it'll probably put it in the upper left, and it'll be this very simple tick up with black text. Now that might be fine for your purposes, and then you click OK, and you're good to go. But for us, I'll show you how to style it a little bit. So we'll go back to the scale bar dialog. Firstly, let's talk about changing the color. So to change the color of the line, we can click here, and let's just change ours to white. Typically, I would stay away from anything besides black or white unless you have a real good reason. We'll hit Apply, and we'll see that the line has changed. But the line is pretty thin, so let's choose a different style. So up here where it says tick up, let's go down to box and hit Apply. So now we have a box that is showing us 2 intervals of a distance measurement, and that's really good, but the text is still black. So let's go here where it says font, click on it, and now we can really deal with the font as much detail as we want. Let's at least go ahead and change the color to white, and let's give it a little bit of a drop shadow like so. And when we hit Apply, we'll get a pretty nicely styled font. Maybe we want to increase the size of it just a little bit. So what we can do is go back to where it says text, and we can just increase the font to 12-point font, and when we hit Apply, we get a slightly bigger, nicer set of texts over here. Now, I don't necessarily love it up in the upper left. I want it in the bottom left. So I'm going to click here where it says Placement and click bottom left, and then I'm going to click OK. And that looks pretty good to me. Now, I told you this is quick and dirty, so we can't really set the size of the scale bar, at least in my version of QGIS. When I try and set the size, it doesn't change it. What you can do is notice that as you zoom, the scale bar actually stays the same fixed size on my screen, but the actual numbers, the scale itself, changes. And one thing I never showed you is that if you want to go to a specific map scale, you can just type it in down here. So if I want to go 1 to 10,000, I can just type in 1 to 10,000 and hit enter, and I'm sort of zoomed at that level. And if I have the little hand tool up here, I can just pan around until I'm viewing whatever it is I want to view at, and my scale stays at 1 to 10,000. And if I want to go back up to like 1 to 100,000, I just type it there, and now I'm zoomed out to 1 to 100,000, which is not, well, it's not quite enough to cover the whole Wadi Hassa with this square window. So one thing that you can do, a little cheat, is you can make your window a little bit bigger and go back here and reset the scale to 100,000. One more zero and hit enter. And now you have a map that is essentially covering the area that you want at the scale that you want. And here the bar is showing 9 kilometers. Let's add one more decoration. Go back to View, Decorations, and then North Arrow. Click Enable North Arrow. And I'll just show you the default is this kind of pirate's map looking North Arrow, which I think is pretty hideous. And so the first thing that I personally would do is to click on so where it says Custom SVG and then there's 3 dots. You ought to have a folder that's shipped with your QGIS that has a whole bunch of SVG graphic files in there that are available. And you can go through the sort of organization to see all of the funny symbols that you could potentially choose from, knowing that some of these are actually for, you know, the actual map symbols, the dots of the sites or something like that. But let's go to arrows and let's pick a nice simple north arrow, such as well, let's see, let's choose this one right here and click OK and apply, and we have a nice north arrow there. Now we see that it has a white outline and a black interior. Let's just match our white theme by changing the fill to white. And there we go. And we might want to change the outline to black. So sort of do it like so. And I think we probably want to increase the size to just a little bit bigger so that we can see it. Now, if you wanted to set what we call a declination, so this is just pointing vertical for north, but if you know, for example, your compass is saying that the North Pole, the magnetic north, is like slightly this way, you can set an angle of declination, like so, to 13 degrees, let's say. I'm just sort of making that up. And it will point that direction to show you which way is magnetic north. But for now, we'll just put that to automatic, set it back to whichever way the GIS wants to show is north, and leave it for there. One last thing that I want to do is this is really tight to the top, so I want it to come down about 10 millimeters from the top, and I can do that. And I can even move it over from the left over here as well with the horizontal displacement. But that is actually looking pretty good, so I'm just going to leave it. And now we have our map, and let's say we wanted to save this view that we have here to a graphics file. What we're going to do is go up to project. Well, first of all, we're going to go up to project and we're going to save our work so that in case it crashes, we get back with our nice map decorations and everything that we wanted. The next thing we're going to do is go to project and go to import export and click export map to image. And we get this dialog here. And basically what we want to do is to make sure that it's saving exactly what we see, so we're going to click to set the extent to match the map canvas extent. By default it might have them, and you can edit these by hand if you know what you're doing, but otherwise if you want to save what you see, map canvas extent. You see the scale is set to what we had already set, and we can change the resolution. Now, generally speaking, higher is better, but higher is also bigger space. We want to save it at least 300 dpi for print quality. If we want something small just for viewing, maybe on your phone or something, you can stick with the 96 dpi. And if we wanted to, we could set the exact size of the output in pixels over here. We can also tell it whether we want our north arrow and scale bar or anything else to be displayed on the image. And we'll click Save. And what we're going to do is to go into a sensible place to save our output, which should be our GIS projects, Wadi Hassa, and then I'm going to make a new folder, which I'm going to call Output Graphics. And hit Create. And this is, I'm going to call this WHS Points Overview Satellite Imagery. So human readable, so that I know what is going on. And now I can save it. By default it wants to be PNG, which is probably fine, but let's go ahead and do it in a JPEG, because we'll get a little bit of a smaller file if we do that. It'll compress it. Click Save. And then now, if I go, remember the shortcut to get to Project Home, right click on it here, Open Directory. So now we can go to our new Output Graphics and we can open that up, and we have a nice quick and dirty map with a north arrow and a scale bar, and at a 1 to 100,000 scale that we set. Alright, so we can do whatever we want with that. Paste it into a Word doc, email it to a colleague, I don't know, print it on a photo printer, whatever you want to do with it. Okay, so now we have figured out how to do that. Let's move on to creating some new layers. So the first thing that I want to show you how to do is to make permanent the filtering that that we did before. So we're going to go back into the right-click menu on WHS sites, go back to Filter. We're going to redo our filter where we go Site Type, we double-click, Equals, and then we're going to get all the values and go down to Village. And we're going to click OK. So now we have filtered just the villages. To make that permanent, we can right-click again on the WHS sites and click Export and hit where it says Save Features As. And we are going to save this filtered version to a brand new separate data file. Remember I said we don't want to be overwriting, and we want to make sure we organize. As we start to create data files, this is where that organization is going to become more and more important. So it's picking GeoPackage by default in this case, but we could choose any of these other vector formats. We're going to leave it as GeoPackage for now. We are going to change the file name. So we're going to go back to our GIS project, Wadi Hassa. I'm going to go into our vector file, and we are going to create a new folder, and we're going to put WHS Villages. Again, I'm being slightly over-organized, but better to be over-organized than under. And then we're going to put the name of our file is also going to be WHS Villages. Click Save, but we haven't created the file yet. We just told it the container where we want it to go. And the display name we're going to change to WHS Villages here. Note that the CRS is the same as the original one, so that seems to be fine. And we'll let it try and assume everything else is going to be here. We'll just click OK. And now it automatically loads the new file in. And we can style it in whatever way that we want. So for example, we can go to the Symbology tab and, oh, I made a mistake here. 1 second. I saved it as a line file. Let's try that again. We'll go to Export, Save Features as Geometry Type. We should hit Point is what we should have done. So we're going to go back to our 3 dots menu. Now I'm actually doing something a little bit dangerous. I'm going to overwrite the WHS villages, but since I've organized myself, this is actually a learning moment, I am not in danger of overwriting my original WHS sites file because I put this in a totally different folder. And double click on that, and WHS villages. This is again just the display name for the thing itself, just in the layer display over here. And so now when I do it, there we go. Now we have, I'm going to remove that false one. Now we have this new points that are just the villages. And you can see it's showing up in brown here. So what I'm going to do is, very quickly, I'm going to change the color to, I don't know, it's just purple or something like that, just so we can quickly see that we have created a new file. And when we go back to the original WHS sites and go to the filter and clear it, what we can see is we have now made permanent our selection of villages, and it's saved in a file, and it only has the village points. All the rest of those points were filtered away. But because the filter can be undone in the original, we haven't overwritten or deleted anything. Okay, so let's talk about some of those spatial queries. And one interesting thing and an example that I'll show you is how to set up a regular survey grid and do some spatial querying, some overlay querying to count the number of different types of sites within the grid that we want. So what we're going to do is to hop over into the vector menu toolbar, and you'll notice that we have a few different submenus. What we're going to do is go down to where it says Research Tools and pick the one that says Create Grid. Now, I do encourage you to explore some of these other ones, like creating random points in different places. But for now, we're going to click the Create Grid. And we can create several different grids. A grid of points, a grid that's just lines, a grid of rectangular polygons, a grid of diamond-shaped polygons, or a hexagonal grid. Now, the hexagon grid is actually probably, from a statistical viewpoint, a better shape for doing a random sampling or a survey grid overlay where we're counting points. But in industry, the rectangle is king. It just is one of those legacies. So chances are you'll be asked, if you're doing this for a CRM company or something like that, to just create some sort of rectangular survey grid. So that's what we're going to do. Now, what we want to do is to set the size of the grid and also the extent, how far across the landscape. And we have a couple options to do that. So the first thing is, if we just click this, it will set the extent to just the view that you're currently looking at in the map window behind you. So exactly the view of what you're seeing behind you, that's where it's going to create the grid. And in terms of the size of the grid, you have to set both the vertical and the horizontal size of it independently, because you might want to make square ones, but you also might want to make rectangular ones. So first we're going to pick the units for a size area of what we got here. Kilometers makes more sense than trying to type in thousands of meters. And let's start with a 3 kilometer grid. So we'll change both of these to 3 and 3. And note that down here where it says grid, it says create temporary layer. So this is another teaching moment. If you know that this grid is going to be correct and you want to save it directly to a file, you can do so by clicking on the 3 dots and click Save to File and type in all the names just like we did for when we exported the filtered site there. Run the routine and it will save it directly to that named file in your tree. But if you don't know that this is what you want, just leave it as create temporary layer and make a mental note or maybe write down that you're creating this thing so that you know when you close QGIS, that temporary layer is going to be deleted. Okay? So let's see how that looks. Hit run. And I'm just going to move this off the screen to the right. And what we see here is the green grid is our 3 kilometer grid. And notice where it put it in the layer order over here. So if I want to pull it down one, now I can see all the other WHS sites on top of it. And that looks pretty good. And I can go into the properties and I can go to the fill and click on the fill color, and I can change the transparency just a little bit so that I can kind of see through it. It's sort of semi-opaque. So you can see the satellite imagery below it, but you can see all of the grid lines very, very clearly. And if you really wanted to, you could actually just make the whole thing make the whole thing completely transparent on the inside. Click OK, like so. Now note, I'll just go back in there one more time, where I did that under the fill color. If I was up here and I changed this opacity, it would change all of it, including the black lines. And it would look, oh my god, it disappeared. That's because you're changing the opacity of the whole layer, not just the fill, the color that's in the squares. So for this application, we want the lines, the outsides of the polygons, to stay opaque, but the insides to be translucent or transparent. Okay, so now we have a grid, and if I zoom out, you'll see that it was just stuck back to the area that we were zoomed in on, which is pretty nice. What I'll do is quickly go back to our zoom level and bring the grid back. And instead of this where I click to get the view extent, I can click on the arrow and calculate from any layer. And so let me do one that is just for the villages, which is not the full extent behind there. And if I hit run, what we'll see is we have another grid called grid over here. And again, these are both temporary files. If I close QGIS, they're going to be deleted. And this one is aligned to the area in which the village sites are found. So you have to be a little bit careful as you're doing this and choose the extent that makes the most sense for your application. Let's do one more where we choose the WHS sites as the extent and hit run, and we basically get a grid that is aligned to that one instead. Now if I don't like some of these, I can right click on them and hit remove, and they are gone, right? Completely and totally gone. I can hit remove that one and it's gone too. And this one, I'll just quickly make it most transparent in the center, like so. And if I bring back my WHS sites, we can see that the grid covers that area very well. Let me just get back to my previous extent. Okay, so I have my rectangular grid. Let me just quickly show you, just for funsies, what the hexagonal grid looks like, because it's pretty cool. Let's just hit that, like so. And now we see, let me just close this, we don't need that anymore. Now we see the really cool hexagonal grid. And for this one, what I'm going to do is make the grid transparent, but change the color of the lines to white so that we have both of them overlaid. So now you can kind of see the two grids, the white grid of the hexagonal. If I make the colors just a little bit, or make the lines just a little bit thicker, that might be nice. There we go. We can see that, and we can see the, I'll put that just underneath, yeah, then we can see the rectangular or the square grid in this particular case. What we'll want to do next is to automatically count up the number of sites that are in each grid square. And that is made simple through, again, the vector menu item, and we can go to the analysis tools, and we pick the count points within polygon, and we get this dialog here. By the way, each of these dialogs has some helpful text over here that tells you what the options are, so I do recommend that you read that, and if you need more help, you can click the little help button over here, and it will pop up another dialog for you. Let's do our, so here's actually an interesting thing. Because we haven't changed the name of these, we haven't saved these. That's the point that I wanted to do first. So let's save the rectangular grid. Right click, make permanent or export, and what we can do is click our three dots, and we're in our vector, and we can create a new folder which we'll call survey grids, create, and we'll call this one 3km survey grid, right? So that's the size that we did. That's at least enough to know what that is when I'm clicking around in my folder. So click that to encode the name, and then for the display, 3km grid, and we'll just leave all of that the same, and now it has been saved. But you see there's two copies, the temporary one and the permanent one. Let's remove, oh sorry, this is the, that's the hexagonal grid. So it has made this permanent, and we should now be able to go into our project home, vector, survey grids, and see our 3km survey grid geo package. So even if we remove these layers, like so, we can access the 3km grid like that. Just again because we saved it to a permanent file. Okay, so let us now do our overlay statistics. So back to the vector menu, analysis tools, count points in polygon. So now we'll have the name 3km grid, and we know which grid we're selecting, so that's useful. And we have WHS village seems to be selected by default here, but we could choose WHS sites. So let's do that. And at this particular moment, what we can do is it'll make a new column in the attribute table called numPoints. We can change the name here if we want, but I find that to be fine. And again, it's going to by default make a temporary file, which is okay for our purposes here. So let's hit run, and it will create a new one called count. And if I right click, open attribute table, I have numPoints, and that is the number of sites that are located fully within each of these grid squares. We also have this row and column index, which is how we know which grid square we're dealing with here. Let me show you one additional thing that you can do here, which is interesting. If we wanted to count the count that we got now is the raw number of all points. But if we wanted to count the number of different types of sites, we can lump them together by field. In that case, we would pick site type. So now, if there's 3 villages in one square, it'll only count that as one site type, village. And the number that we get from this tells us the number of different types of sites, not the total number of sites. And let's go ahead and hit run on that. And we have another count over here. And if we open that attribute table, we see the value is going to be different than the previous one. So let me get those side by side so that you can see them. So here we have the same grid ID 00, and it has 22 individual points, but 13 kinds of sites within it, right? And you can do that for any field, any index that you want. Okay, Now we're getting somewhere. If I want to make those permanent, again, I can make permanent in the same way. But for now, I'm going to move on. I'm going to remove them just to make it clear. And I'm going to hide the WHS sites. And I'm going to hide the 3-kilometer grid. And I'm going to talk about the digitization component. What you're going to want to do is to zoom in and find a village site that seems to have some archaeology around it. Now here's one, and these are archaeological features probably. There are some new features, some new modern buildings here as well. Let's zoom out and find another one. Let's see about this one. This one is less clear. There are some things, but there's not a lot that we can see. Basically what we're trying to find is a village site that seems to have a goodly number of archaeological features that are on the surface around them, because what you're going to want to do for this is to digitize those features. This particular one, for example, has a few up here, but it has a lot of this sort of more recent agriculture and some more recent buildings. So let's see if we can find a really, really good one. I think there was one, if I'm recalling, somewhere over here. Is it this one? No, that's the one we were looking at before. This has some stuff here. I think that first one we were looking at probably had the most. Let's see, if we go further east we might get luckier. That has a few. I'm going to pause for just a second while I find a good one, and then we'll come back. Okay, I recalled the ones that I found earlier. They are over here in the sort of western zone, and I'll give you 3 good options. Maybe 4 actually. 84, 56, 23, and 20. So I also turned the labels on, which is helpful to know which sites we're dealing with. And you can explore those, but I'm going to deal with site 23 as my example. Okay. So we are going to do a sort of digital survey or a satellite survey, a desk survey, using the high-resolution Google Earth imagery. And for this one, we're going to just try and keep it to a zone around the site. So one way to help us know where to stop is to create a buffer like we talked about in class. And we can do that in a couple different ways. Firstly, we can go back up to the vector tool box up here, and we can go to the geoprocessing tools and click where it says buffer. And by default, whatever we have highlighted over here, the villages, is already highlighted, but we can select whatever layer we wanted. And we can create a fixed distance buffer in any of these metrics. So for this, let's start with 500 meters, just see what that looks like. And we can, I'll talk about some of these other things in just a second, but let's just hit, sorry, I should hit run before I move it off the window. Hit run, and we can see, oh my goodness, that's huge. That is way too big for what I want. And also, it looks to be almost like not quite round. So let's fix the roundness part first. Where it says segments, we can create higher segments, and that will create a rounder looking buffer. So with 20 segments on an arc, we get much closer to a perfect circle. And if we look at the difference between those two, it's pretty obvious. This is more important. The larger the buffer is, the more you're going to notice that the segments. Why it gives you the option, I'm not 100% sure. Maybe because smaller segments make smaller files. But 500 is way too big. Let's go down to 50 and then hit run again. And now we have that. And let's hide the other two And 50 is not quite big enough, so let's go ahead and up that to 200 and see what that looks like. That looks like a doable area for my particular site. So I'm going to put this off to the side, and I'm going to go remove all the other temporary buffers by right-clicking on them and hit remove. And I've got my 100-meter buffer over here. And I am going to make that permanent. And again, I'm going to put it in my vector folder. I'm going to make a new file that's called buffers, and I'm going to call this one 200 buffers. And actually I'm going to put villages in the front. Villages, 200 meters, buffers. Okay, so we have that saved away. Now, remember I told you you could use an attribute column to figure out the size of your buffer? Let's just see what happens if we do that. So I'm bringing my same buffer geometry buffer window up again. And here where the distance is, right here, this little like, I don't know, file drawer looking thing, I can actually click a field type and I'll pick maximum length. And now it's going to read that value directly from that column over in the attribute table. And when I hit run, it will grow the buffer the size of the maximum length the surveyors estimated the size of the site. And what's really interesting in our case here are, yeah, we were pretty close when we looked at it 200 meters or so. We got pretty close to whatever the surveyors decided was maximum length. Now technically maximum length should be divided in half for a radius, so I think we actually did pretty good with our guesstimate over here of 200 meters. The difference is that we applied 200 meters to every single site. All the villages have a 200 meter buffer, whereas if we read in, we see they all have different sized buffers, which is kind of nice. Again, we would probably want to make that to be half the size, so we'd have to make a new column and do some math in there, but that's okay. In Grass, we would be able to add a scalar to do that in the dialog here, but I don't think we can do that in QGIS. So, basically what we did, oops, I ran it again. Basically what we did is we just set up a survey boundary for ourselves. And what I'm going to do is to quickly make that permanent. And we're going to do that within our buffers folder. Villages max L buffer. And save that. Okay, so now I've saved both those buffers. And I am going to quickly style it so that the fill is transparent, just like we did with our grid earlier. And that's just going to help me know where to stop my digital survey. Okay, so now make that black line just a little bit thicker so it's easier to see. There we go. So now I have my survey area. We have my central point here, and I can start doing my digitization. And for this, we have to create a brand new blank vector object, and we have to format it so that it will be the right kind of vector object, point, line, or polygon, and will give us some starting column names for fields of attributes to fill in for each new thing that we're going to create. And I just want to call your attention to the project 1 file, description file, and all of this is in text. We're going to create two fields. One is going to be type and one is be condition. And the type, we're going to go with if we go into our Wadihasa project file under vector and find the database codes, we have site type codes. We're going to use the same codes that the surveyors used. I'm going to open that up. You're going to want to have this open off to the side so that you can read it. So these are all the different site types, and these are the codes that we are going to use. So I'm going to put that off on my other screen for now. And then the other set of codes, we're going to have a field called condition, and we're just going to use this numeric code 1, 2, 3, 4 to indicate qualitatively how nice the thing looks. Okay, so basically something that's modern, still in use, something that's antique but restorable, something that is ruined, and then I have no idea, I can't tell. Okay, so with all that information in mind, let's go ahead and create a new blank vector layer to work with. We're going to go up to where it says layer in the menu dialog, and we're going to click create layer, and then you should choose either GeoPackage or Spatialite, and only if you have a really good reason should you pick some of these other formats, and especially shapefiles. I wish they would die, but they unfortunately are still around. Unless you have a supervisor who's telling you they want shapefiles, or you're trying to do backwards compatibility with some old computer or something like that, I think we can move on from shapefiles. They're just such a pain. I don't want to deal with them. You can choose, again, Spatialite. We're just going to stick with GeoPackage because it's a very flexible container for vectors. So let's click on that. And firstly, the database is actually the container, the file name that we're going to create. And we're going to go into our vector folder in our Wadihasa project. And what we're going to do is to create a new folder that we're going to call Site 23 Satellite Survey, or something like that, just so you know what is going on. And now we're going to call this individual file surrounding features or something like that. Again, you can choose whatever name makes sense to you. Okay, now we have all of that here. We have to choose a geometry type. Depending on what the features look like, you can go with lines or polygons. I'm going to stick with lines because most of the things are actually going to be linear. We got a lot of like rock alignments and stuff. Technically we could, well, okay, I won't go there. Let's just choose line string. Now you'll see all these multi things. This is what I want to avoid. GeoPackage is capable of containing multiple geometries. And when you become much better at this, you can read up on multi-line versus single line and multi-polygons and all of this other stuff. And there are times and places where that will be important to do. But to keep it simple, we're going to use just these kinds of geometries: point, line, string, and polygon. And essentially each object we create is going to have just one geometry, one line composed of arcs and nodes, one point or one fully closed polygon. Okay? Just for now, to keep things simple with ourselves, I think it's best if we just choose line string. Okay? Notice that it's choosing the CRS 4326, which is latitude, longitude. And in fact, if we click on that little button here, and this little exclamation is saying it's not matching, right? We can choose the UTM zone 36 north that the rest of the files are in, and we should be okay at this particular point. Now we want to create our two attribute columns. The first one is going to be a text column, and we are going to call it just type. And let's give it a maximum length of 10 characters because we're using the code. Let's truncate it. It'll save a few bytes of data on your disk. And this is really important if you have really large files you're going to create. But for now, we'll just keep it at 10. It doesn't really matter, but let's do so. And at that particular, we're going to click Add to Fields List, and we can add a new another one, and we're going to call that one Condition. But remember, we're going to use a numeric code, so we're going to use integer, because all we need is 1, 2, 3, 4. We don't need to store all of those bits and bytes of data. Remember that we were talking about, you got to know this stuff. But for now, we're just going to do that. And of course, we could create more and more fields. If there were more attributes that we wanted to record as we were doing this, we would want to make sure that we create fields for those. But for this one, we're just going to go with this right now. I'll just point out real quick that there are some advanced options, but you don't have to worry about them at this particular moment. So, right now we have our surrounding features file. It's completely blank. The container is saved in the folder, but there's no data in it. This is a good moment to go ahead and save your project. Now remember, saving the project just saves the configuration that you're viewing at this particular moment. It doesn't save any of the data files themselves. Okay, what we're going to do now is to open this up for editing. And to do that, we can right click on it and click Toggle Editing, and you'll see a bunch of tools just opened up over here. Now, the first thing you'll notice is that we have this thing right here, which is the other way that you can toggle editing. So I can turn it on and off by just clicking on it over there. And what we'll do is simply kind of zoom in until we get to a point where our eyes are saying that's blurry enough. We can just start drawing in our things, okay? And to do that, we'll click where it says Add Line Feature. And now you'll see I have this bullseye. I can just start clicking, and I'm just going to very quickly outline this. And when I'm done, I right click. I click my last point, and then I right click. We'll leave the FID to auto-generate. This is just a unique numerical identifier. And then we'll use our type, our types. Here we are. Hey, come on, fly. There we go. Our type codes, oops, which is here, to decide what we have over here. And you can decide if any of these things are useful. I mean, this is for surveyors out in the field, so they don't have like room, but we do have domestic cluster, perhaps, or enclosure, which might work. We could also potentially use other, if we don't really know what's going on for this. This is not just a rock alignment. It's not a circular stone thing. It's not a complex necessarily. We don't think it's a temple. We don't know. We don't think it's a tomb. So I'm going to choose either enclosure or domestic cluster. And for this purposes, I'm just going to guess DM_CLST. And I'll type that in over here. And the condition, I would say, just guessing, it looks like it could be restored. So I'm going to give it a condition of 2 from our list before. All right, and now I've done that. So now I have another thing, and maybe I want to call all of this area one thing. So I'm just going to click again and keep clicking around it, being as careful as I can to get the geometry about right. And then I'm going to right click. I'm going to call this one also a DMCLST, domestic cluster, and I'll give it the same code like so. Right? And now I can use my mouse wheel and zoom out, and wherever I'm pointing my mouse wheel, it's zooming. So I always find it easy just to navigate by zooming out and zooming in. But you can actually go up and grab these tools, but you have to make sure you click to add a new line here. Now here is a linear feature. I'm just going to continue to click it and kind of end somewhere here. And this one I'm going to call a rock alignment. So on my other screen over here I can see that. And it is RCK underscore AL, and I'm going to call that kind of destroyed. All right? And you can just keep going. You have all of these things that are within your survey circle. And you can be methodical and start in the middle and work your way out. You can kind of jump over here, and here's a couple more rock alignments. So 1, 2, 3, 4, 5, 6, 7. Oh crap, I messed up. Hit cancel, start again. 1, 2, 3, 4, 5, 6, 7, 8. Right click. RCKAL. This one looks pretty good, so I'm going to call it 1, like it's being used right now. Now, at this point, what if I made a mistake and this didn't quite, cover? Like if I zoom in, I don't like this point over here. What we can do is to go up here and choose the vertex tool. Let's just say for the current layer, and I can click that, and I see I'm moving it around. Wherever I click again is where it's going to end up. So I don't have to always hit cancel. I can live with my mistake for a little bit and then go back and do the fine adjustment. And if I want, even between the vertices that exist, I can add a new one like so, and I can move it around and add some complexity to the geometry should I want. When I'm done with that, I can right click and it's done. Now, here's a tip. This save button is different from this save button. This button saves the edits you're making in the file for this vector only. So as you add new features, you're going to be clicking that save button. That way, if the program crashes, everything you did will be saved in the file. You just can reopen the file, toggle the editing back on, and you can continue editing it. This is the save for the project file, just the view and the layers that are stacked to the left. So basically what you're going to do is continue doing that, and you're going to put all of these features, you're going to digitize them, and you're going to put codes for the type, and you're going to put codes for the condition. And once you have all of those things encoded, next week I'll show you what to do with that information in terms of creating a beautifully styled map of all of the archaeological features that surround village number 23.